Good morning. I hope nobody has a headache. For the benefits of the viewer who sees us via video, yesterday was party night at PDC, and a lot of people drank a lot of alcohol. My name is Clemens Vastas. I'm Principal Technical Lead in the Windows Azure Platform App Fabric team, formerly .NET Services. It was a little shorter back then. Our team built two components of the Azure platform called the Access Control Service and the Service Bus. So as we were talking to customers, in our TAP program, as we're building stuff on Windows Azure, because the Service Bus and Access Control are one of the biggest tenants on Windows Azure. We're built on top of the Windows Azure platform. We're leveraging the table storage. We're leveraging queues. We're leveraging Azure Compute, obviously. And so there's a bunch of best practices and ways how we build things. So I want to talk a little bit about those in the context of a little sample that may be familiar to you. So the goal is to explain what a hybrid cloud application is, what that means. How do we communicate across hosting sites? And what does that mean with hosting sites? I'm taking a familiar demo. You're going to hear about that just in a moment. And I'm freeing that from its localhost jail. And then there's going to be code and patterns and practices and all those things. The code will be on my blog within the next day or two. There's already something on my blog, like probably the coolest component of this that you can already use. And I'm going to point you to that as well. So here's our familiar distributed application. We have a web storefront. In that application, there's a web backend service tier, a set of web services that are used for that web storefront. In that web backend tier, there's a notion of a restaurant service and a menu service, and we have a transaction processing tier with an order processing workflow, and payments and discounts. We have an in-store kiosk where the orders are being actually handled, where we have an order handling workflow. We have a delivery driver who's driving stuff around, who has a mobile UI, and an on-device tier. And then we have a set of databases. The application is called Dinner Now. So if you're familiar with Dinner Now, this will be familiar to you. If you're not familiar with Dinner Now yet, you go to dinnernow.coplex.net, and you can go and download that demo. So the code I'm going to give you within the next few days via my blog will be a modified version of the stuff that sits on Coplex, modified in the way that I'm showing that to you here. So what is dinnernow.net? Again, for people who haven't seen it, it's a very popular Microsoft sample that was first published when we came out with the Windows Workflow Foundation and the Windows Communication Foundation, and has been updated since then for .NET 3.5 and 3.5 SP1. Now showing Link, it's showing PowerShell, it's now showing even the .NET Compact Framework. And effectively, it's a home food delivery kind of application. So, and I changed the story a little bit, or I actually made a story around this a little bit more than what Dinner Now had as an original sort of background story. So let's talk about that briefly, what dinnernow.incorporated is. So Dinner Now Incorporated is a little company that sits in Seattle, and that company is offering delivery services for restaurants, so that the restaurants don't have to have their own drivers. So they have a website, they partner with all the restaurants, and they have a site somewhere in a high-rise building in Seattle in the city, and that's where they run their business. They have a website where you can go and order, you can browse menus from all the partner restaurants, and then you can go through them. The order gets dispatched to the restaurant, they cook the meals, the drivers get dispatched to the restaurant, and then picks it up and brings it to the customer. So the way this looks, for those that haven't seen it yet, here's Dinner Now, and now I'm going to go and look for some lunch within 30 minutes. So here's the Northwind Bar and Grill. And I'm sorry that the pictures don't show up. That's a bug in my app. That's actually an intentional thing, but because I just didn't do it. I'm signing up. I'm already registered here. I'm picking one of my very valid Amex cards, and I'm saying, bring my meal, and then that ends up showing up in the Dinner Now panel here. And then I can go and set the status to, oh yes, we cooked this, and then the driver is going to come up and is getting notified on his little mobile application. And then they basically just get the details there, and once they have delivered the food, then they press a button and they're done. So that's effectively the little workflow here. Showing the workflow and talking about the workflow using the demo is a little challenging. Therefore, I'm going to explain that using the slide. But that's the basic notion of it. Here's why Dinner Now is really interested in the context of Windows, Azure, and the Service Bus, because it really is existing code, right? It's not designed for the cloud. This was built 3 years ago initially, and then got updated. But nobody ever thought about putting this into the cloud. And you can tell nobody actually ever thought about running this on more than one machine, which is kind of funny. Because it really is there are a few tiny little things which sort of assume co-location of databases and all those things. So I had to make some changes in that area, but not the big ones. There are things that you cannot run in the cloud in this application, and that's very important. Dinner Now has 2 points of very direct, necessary physical tie-in. So first of all, it's this kiosk application, right, where the orders come in and then you go and serve the orders. It's a WPF application running full screen in the kiosk. And of course, the idea is that someone with really fatty fingers can go and just on his touchscreen go and just check the orders out and look at them. But this is happening on premise. The next thing is the delivery application for the driver. That actually can't run in the cloud either, because that needs to have an on-premise component. So there's a bunch of things that must run, that have physical tie-ins into the real world, can't run in the cloud. You may do those via a web page, but for an application that, for instance, runs in the hands of a driver, there may not be connectivity everywhere. They go into tunnels, they go into buildings, and so you rather want to have an application that's not web-dependent, but is web service-dependent. And then there's stuff that you might not want to run in the cloud. And that really depends, and this is a touchy subject, but now here's DinnerNow.inc, that little company, which is very, very protective of their customers' personal data, including credit card data. And since we're early in cloud computing, they feel a little uneasy storing that data somewhere in the cloud. And I think that's a reasonable thing, to be protective of that data. And, but there may be other data. That data may be sitting in their CRM system. So they already have that sitting there, and you cannot easily separate this out from the CRM system. You can't just arbitrarily go and just move stuff off the CRM system up in the cloud. So they just may want to run their customer profiles. They want to retain those on site, but still move the thing that requires scale, the website, up on premise. So the real reason why this is really interesting is that's like your stuff, right? When you're looking at your application scenarios where you're going through and you're all here and you're interested in the cloud and what that means, and every single one of you has existing applications, you're thinking about, hey, what can I do with my app to make it work in the cloud? Because the last 10 years we all spent in making data flow better between applications. We've integrated things. We have this app, and we made it talk to each other. We were all about web service and all those things, and all of a sudden it's the cloud, and I shall take a thing and just move it up there, and then how does that talk to the stuff that I already have? And so that's a big challenge. So let's talk about the flow of Dinner Now and how I think about this and how we can develop this into an architecture. So this is the thing that I found. So I took Dinner Now, I opened it up and said, I'm going to port this thing. So it begins with the customer browsing the site for food. So the lady here goes and is hungry, as you can see. And so she goes to the site requests information about restaurants and menus from the backend services. The backend services talk to the catalog database. That is embarrassingly, so that use case, that flow is embarrassingly easy to move into the cloud because there's really nothing to it, right? You have a catalog database, a menu database, the data almost never changes. You just take the catalog database, move it into SQL Azure, you take this web service tier, which deals with the restaurants and the menus, does the lookups and filters and whatever it does, and the web store, just move all that to Windows Azure, happy. So that's simple. Now she has decided, hey, I want something, and the customer wants to order the food. Now the site asks the user to log on or register and collects the shipping address and the credit card information. That goes into a different database. That goes into the profile database. The profile database may be, and it's in this case, just simply the ASP.NET built-in profile DB. But for the purpose of discussion and too complicated to ship, at least as a demo, let's assume they have a CRM system, even a simple one, and that's what they're hosting on site, and that's where the data goes to, and that's where the data comes from. So all of a sudden, now you have a link from the web storefront, which runs in a Windows Azure cluster in one of our data centers, and that now wants to talk to the CRM system on site at dinnernow.inc, which runs on servers somewhere in a high-rise building in Seattle. How does that happen? And then once the profile has been created and the profile has been looked up and the user has been validated, then we go and submit the order for processing. And then when we think about order processing, what does that mean in a company that deals with all the restaurants? Well, ideally, everything is electronic, right? So you have a restaurant, and this is the premise of Dinner Now. The restaurant has a computer, and the computer runs the app, and automatically everything flows electronically if that restaurant cooperates with it. But it may very well be that the way it actually turns out to be in a real implementation is that at Dinner Now Inc., if that restaurant isn't linked up, a screen pops up and say, hey, call this number and tell them to cook the following meal, or send them a fax. So again, tie into the physical world, someone is calling him, or you have a fax machine that you need to go and send stuff out with. And it turns out neither the Google Cloud nor the Amazon Cloud nor we have fax machines in the cloud. So the order comes in, the order gets processed, we're applying charges, discounts, loyalty points, all the things you could do. Now, the demo doesn't do that, but that's what I would do if I would run that company. I would have a loyalty program. I would handle all those loyalty programs in my little CRM system, and then do all the local processing. Again, that's something that dinnernow.inc does. And then the order is then routed to the fulfilling restaurants, including phone and fax. So we should not neglect this. And then the restaurant personnel interacts with that kiosk application I just showed you briefly, and then prefers the order for delivery and pickup. So now we just transitioned to another site here again. Now we are in a restaurant. And the cook is probably looking directly or is being told that here's what's needed, and we'd like to have that within the next 30 minutes. Then we go and route that information about that pending delivery to a pickup, to a driver who's going to pick that up and send that out. Now we have a fourth site, a different site, and that's a mobile site where someone drives around and has probably a mobile device sitting mounted right in their car and a device in their hands, or in a convenient place, probably on their arm, in their watch, whatever. to go and know about where they need to go, where they need to pick things up, and when they need to bring things. And then he accepts the route, and then picks up the food at the restaurant, and then finally delivers the food or the pizza. So in that scenario, what really runs where? So how would we go about taking that application and now actually deploying it to different places? We've developed that now. Let's go and summarize that, and where would that all happen? So in the cloud, or more generally, in any hosting environment, a hosted environment, that's where the web storefront and the web end service tier is, and the catalog database would be. That's how I would place it. That might be Windows Azure. That might be some other place. No matter whether you run it in Windows Azure, or you run it in Amazon EC2, or you run it in some other host with one of our hosting partners, and we have a big community of ISPs who are hosting for Microsoft or Microsoft platform, it doesn't really matter. If you're hosting somewhere in someone's data center, you're going to have the same problems, and the service bus is going to work with all of them. So the discussion is relevant for any of those environments. So you have in the cloud, you have running that web storefront and the service tier. That gives you all the elasticity you need. So you can in Windows Azure, you can go and scale up, scale down. You can deal with spikes because most of the traffic is going to be about sending pictures, and they're cached, and they're sitting in the catalog DB. Is really about the presentation, and then the flow for profiles, flow for orders, that's actually minimal. This is just a very small subsection of that traffic. At dinnernow.inc, oh no, so here's so that's a web role. That's a web role because it hosts HTTP web services. And then that I would put into SQL Azure. So here's a little bit of best practice from building stuff for internal use. So a little story on the side. The Windows Azure Platform App Fabric, so the stuff that we build, we have a bunch of features, right? So we have service bus, and we have access control, and these are all the things you interact with. That is probably a quarter of the code that we actually needed to write to run our system. Because if you walk up to our service and say, hey, I would like to have an account, there's stuff that needs to be happening. We need to provision live DNS for you. We need to set you up with new keys. We need to set you up with all kinds of things. So that's the internal provisioning system that we have. That's just an enterprise-grade provisioning system. We have a deployment system. We have all kinds of internal systems that are sitting behind the scenes. And we built all of those systems on the Windows Azure table store. And that's mostly because of interdependencies and how the teams got ready with their stuff. And the SQL Azure guys said, please don't. And we said, OK. So my choice here for this is SQL Azure. The reason for that is, very simply, DinnerNow is a SQL database, has a SQL database, and I could take that database, basically just go and export it, edit the script, literally by the step-by-step instructions that are in the docs for SQL Azure, put the database up in there, took along with the data, happiness. It just worked. How would you choose between the table? So as someone who's implemented on top of this, not as someone who owns either of the technologies, but I think it's my job to give you a little bit of guidance. If you have a relational database and you tend to have already an existing schema, and you have some transactional operations going on there, and you have any existing code, SQL Azure is great. It's the optimal choice. For data for systems where you have a lot of reference data, you have all the stuff that fills up the combo boxes. If you work in the financial industry, you have screens with 200 entry fields, of which 180 are different combo boxes with codes that you need to enter. All that stuff, it's actually pretty nice to put that into the Windows Azure table store. So that's the way I look at it. It's a very, very simple, the Windows Azure table store is a very simple model. It's actually very good for few writes, very many reads. And the more transactional things get, the more I would personally have a tendency towards SQL Azure. And of course, now both of those teams are going to come forward and stone me.
Better how? Better performance? Better...
Oh. It's just, I think from a programming experience and from a productivity experience, then you're seeing the gains. Because the SQL is a transactional database, and there is a notion of batch updates in the Windows Azure table store, but that's not the same as a transaction. So there's no notion of a read lock. So whenever you have transactional updates, whenever you have a relatively complex relational system, and if you need to look up by criteria that you cannot put into the row keys and the partition keys, then you end up having an easier time doing it on SQL Azure. If it's embarrassingly easy, if the model is not complicated, then it will be easier tends to be easier on the table store. The way I'm personally mapping capabilities to the OS capabilities we know is that the Azure table store is more like an access database or even the registry, and SQL Azure is more like, well, SQL. So whenever you're tempted to use a very simple ISAM kind of database, then that's a good choice for using SQL Azure or even flat files. So at Dinner Now Inc., that little company, we're running the transaction processing tier on Windows Server 2008 R2 in a service. Of course, this would be, once released, something that runs perfectly well on App Fabric. And App Fabric is actually designed for that case because the order processing service here in Dinner Now is implemented as a workflow. So that's an ideal scenario where we just go and host that workflow in App Fabric. And the little host that I wrote is something you wouldn't have to do once App Fabric comes around. And then the profile database that just runs on SQL Server 2008 at that scale, I would say that's a standard edition that just runs on site. Then we have the restaurant. Here we run on Windows 7. We have a Windows 7 service that we're hosting that in. That's, again, a workflow. And then we have a SQL Express database. And then, of course, on the driver, we have a Windows Phone, or whatever phone you like. Let me just make that very clear. I, contrary to a bunch of traders that I work with, have a Windows mobile phone. So here's how this maps to the physical world. So now we had technology mappings. So we have the cloud, we have Dinner Now Inc., we have restaurant, we have devices. Here's how that maps. So down in the bottom, that's the data centers that we have. So this is running in America. So this is running in either our South Central or North Central data centers, in one of them, depending on how you set the affinity. And then there's very many sites around the Puget Sound area where that may run. We have the sites, the restaurants. We have one site that's the orange one, which is where Dinner Now Inc. is located, and we have the drivers are running around. So it's also geo-distributed. And you can imagine that the yellow ones are moving because these are the drivers. So now we have the challenge of building one app that's distributed across all of these sites, and we need to be able to organize them, and we need to be able to discover all of them. If you now go, if you take the Dinner Now example and make it more real, you find that, oh, I need to talk to this restaurant. And that restaurant sits somewhere in a strip mall, and they have a DSL or cable connection from Comcast, or from Verizon, or from Quest. That's the options that we have, and that's pretty much it. And they don't have networking staff. No, you just roll a computer into their house, and you run an app, and you don't change anything in that environment. And now I need to go to Wenlong's Chinese restaurant and just push data into their place. That's hard. So why is this also difficult? Why is making this scenario real? Why is making dinner now real not so easy? I would claim that dinner now, the thing that we published 3 years ago, is almost impossible to do right, to do in a cost-effective manner without the technology that we're bringing with the service bus. Because it would just be very expensive to maintain all the little network tweaks and tricks that you need to do to actually make it work. So how does the website get at the personal profiles and the credit card data if we don't want to host it in the hosting environment? How does that work? How does that link function? How does the website push the orders out for processing? How does the order process find and push to the restaurants? How do you push alerts to the drivers? And how does the driver check in with the restaurant? All really difficult interconnection problems. So let's take a look at a little bit behind the scenes of this wonderful demo. I have this order. So let's take a look at what happened, and I'm now very happy that this worked. So there's stuff happening here. So I just hit refresh, and there's stuff happening here. Incoming connection for port 1433. There's also stuff happening in this little window here. Some of it more ugly, because I got some stack traces. I got stuff like this. So what you're looking at here is the Cloud Trace Recorder. It's a very simple little console application that's using one of our SDK samples. There's a Cloud Trace diagnostics listener that I plugged into most of those applications, most of those pieces that are now in Dinner Now. So for instance, if I go and look at the Dinner Now web application, the web UX in the web config, and look for the diagnostics section, I find here, and that's straight from the SDK, I added the Cloud Trace listener. So the Cloud Trace listener, I put that into the common assembly here, so I just moved that code over. What that thing does is it implements a little cloud listener on top of a net event relay binding provided by the service bus. The net event relay binding is a WCF binding, and what that does is it provides a multicast channel for one-way datagrams. So what's happening here is I have implemented a cloud listener. More precisely, my colleague Philip Richardson has implemented that thing. And so we're just pushing all the data that we're getting out to, here it is. There's the Cloud Trace Recorder. Utility classes, here's the Cloud Trace listener. So that's the trace listener, and what that thing is doing is it basically goes and sets up a channel factory with the net event relay binding, and then whenever something gets written here, we write that out to the trace channel, and the trace channel's contract is exactly like the contract of the trace listener, so we're just remoting this out. Now the interesting thing is, because that's multicast, I can now subscribe with the listener to all those events that are coming in, and this way doing diagnostics. That is really useful, because what just happened here, and that's with the stack trace, the application is intentionally a little buggy, because otherwise I couldn't show you this. Something just happened in the cloud, on the Windows Azure machine. I see in real time when something breaks. I can fully instrument that application, no matter where it runs, and that may even run on Amazon EC2, wherever you can run .NET code. And then I can go and get those events. And you can now go and take that data stream, the diagnostics data stream, consolidate it, analyze it, and you can listen on multiple places. If you have a problem in production, you tell your developers, and you have it properly instrumented, you tell your developers, hey, you guys look at it, and every single one of them can open the trace window and just listen to the same events as they flow out of the fabric. So that's eventing, used for diagnostics, very useful. So that's the foundation that was even not in the scenario. The other thing that you see, and this is when it says connection 27 created. Let's see whether that happens again. I don't think it will. No, it's still using connection 27. What is that? We're getting an incoming connection for port 1433. Port 1433 is what? Exactly, it's SQL Server TDS. So we said that the on-premise database, the profile database, that lives on this machine. And the cloud, so the Windows Azure cloud, is now talking to this machine to get the data. No tricks, nothing in the hat. That's how it is. So so the Windows Azure cloud, where this is deployed, and as proof, here is the address. So that's all in cloudapp.net. So which means that's deployed in Windows Azure. I can actually show you here where my roles are. So that's CVSB demo. That's my web role, CVSB demo-SBC. That's where my service tier sits. And so we're just looking at the CVSB demo cloudapp.net. We're looking at the Windows Azure thing. And whenever I go and trigger this website, and it needs to go and reestablish the connection to the profile database for here, then it's going to connect in. So let's go and just sign out once and just create a new account so we can see that. So I'm going to just go and register. I accept the terms and conditions. Who was that in the keynote who said, oh yes, and of course, oh yeah, that was my boss. So it's Henry, and then we're just going to make it easy for ourselves. Henry at tempuri.org. Let's do that right. Security question and security answer is actually a funny thing. I know it's an A side, but I think that's the actual security risk in the world. Because people think of a really, really difficult passwords, and then they're typing something completely ridiculous into security answers and questions. And then someone just needs to go in and just say, hey, recover that password. So I'm just submitting that profile. Profile has been created. Now I'll go into my local SQL server, and this is localhost SQL server, right? And I go and execute that query again, and here's Henry. So I just ran that in the cloud. The database connection was made through to my machine, and I just executed that. Now, you may now be confused because of things you've seen in the keynote. Because in the keynote, we showed something that's called Project Sydney. Project Sydney is a VPN-like technology. What they did, and what you may have seen, is they have made the local machine part of the VPN that's made up of a set of machines that are sitting in the cloud. So it was a VPN integration, very low level on the network. That's something that's really great, specifically if you need things like complete AD integration, that kind of flow. What we're doing here is a little different. We're doing point-to-point surgical point-to-point connections where we're not intrusive into the network at all. I have a TCP listener here that's listening locally, and I'm taking that port and projecting that out to the other machine. So how does that happen in the app? I have something that you can go and download right now called Portbridge. Portbridge is something that I published yesterday, and that sample is actually a little older already. It's about a year old. But we haven't published that yet. And what Portbridge does is it allows you to do multiplexed connections through multiplexed TCP or named pipe connections, any protocol. It's just pure TCP or named pipes. Multiplexed connections through the service bus between an agent, which listens on behalf of the service on the other side, and the service, which takes the multiplex stream, demultiplexes it, and then dispatches that onto a target machine. There's a lot of configuration options for this, how you can protect your network. It's not that you arbitrarily open things up, but you very selectively say, for instance, here, let's go and look at that for quickly. So you can say here, please add my local machine and only allow port 3389. So allow RDP access to this box. You can also point at other boxes and just say, hey, this agent is now able to point at all those things. And then from the client side, you can go and access those. So you have so here's another set of examples. You can also map some other machine. Here, for instance, SQL. You can map pipes, so you can allow access to pipes. And then here is the respective mapping on the client side for that tool, like this. So here we're saying, hey, please take local port, because my local machine has RDP, so I can't use that port. Please use the local port 13389, map that to the target host on the other side that has the following name, and the remote TCP port 3389. So please build me an RDP tunnel, and then constrain this so that you can connect to that sort of tunnel port from any other machine in the network, as long as they're compliant with the following firewall rules. This has nothing to do with the actual Windows firewall. This is just an additional mechanism to lock things down. So by default, you can only connect from the local machine. So that's the thing that I published yesterday, and that's built in straight into this demo. And I'm actually giving you the assembly with the sample, the exact assembly that I'm using in the demo. So it's not only the 2 exe files, but you can actually you can embed those things into your app. So that's what I've done here. I have Portbridge is running. Portbridge is running right here. That's the app. And that's now mapping my SQL server out. And I have in my role inside of Windows Azure, let's go there quickly. So in the services role, did I click right?
So what port did you actually have to open on your firewall?
To make that work, nothing. Yeah, service bus always connect. So here's the thing. So if I have a local machine, so I have a local machine and so I'm running the agent right on the SQL box. The SQL box can be totally stealthy. Nobody gets into it. What I'm doing is I'm taking that particular port and I'm basically projecting this into service bus, but not as a pure TCP port, but as a .cf contract effectively. That is governed by the access control service. So you're not opening up the firewall and you allow everybody in. No, you have an endpoint governed by the access control service that you can put rules on, and now you use the agent to complete the tunnel that creates a duplex connection, and then for the agent you need to supply the right rule. So you're getting an authenticated socket through that that allows you to stay stealthy on the raw TCP protocol. We're securing TCP protocol here, or we're securing with federated security named pipes here. That's also why this is relevant. So in the service thing, I have two roles. I have the DB bridge, and I have the regular service host that's hosting my regular HTTP services. So DB bridge is a worker process, and the worker process here is implemented in my DB bridge project. That's the worker role. So the code is very minimal because most of it sits in this port bridge assembly. And what this really does is it goes and gets the TDS instance endpoint. So I have configured this role here. When you go and configure roles in Windows Azure. So this is a Windows Azure package. I'm doing that with the Windows Azure SDK, and now I'm configuring that role. I'm looking at the configuration of that role, and I'm looking specifically at endpoints. What I've done here is I specified an endpoint called TDS. That's type for input. It's TCP 1433. So now I'm actually listening here. The Windows Azure role is now listening on port 1433, or more precisely, this is the firewall rule. And that gets mapped into an actual port which is listening. This is the firewall rule, and this is the load balancer rule. If you set this up, the load balancer will now host that port for your address, for your role, on the LB, and route to you. You're actually listening on a different port on that machine. You're listening on port 20,000 or something like that. How do you find out that port? Well, you have to reference this, and this is what this line is for. You go and say, hey, what's my actual port that I'm listening on? And then you go to the role environment, current role instance endpoints, TDS, IP endpoint port, and that will give you your port that you can listen on. And we need that because we need to go and tell the TCP client connection forwarder, which is already inside that port bridge assembly, which then takes the namespace, it takes the issuer secret, it takes the target machine that you want to go to, it takes the local port, and it takes the remote port you want to connect to, and it also takes an indicator of whether you want to go and use the hybrid connection mode, which we do by default. Hybrid connection mode that we use in the service bus first connects a relayed connection through the service bus and then tries to go and upgrade that connection to a direct socket if there's direct connectivity possible between those two parties. So that's really all this role does. The role that hosts that little TCP client connection forwarder. You can look at the code. And what that thing does is relatively obvious. It opens up a TCP client, a TCP listener, listening on that port. Whenever a request comes in, it goes and accepts that socket. It takes that socket and then multiplexes, and then creates a multiplex set of pumps, and then remotes that socket over there. Now you will say, hey, how can that be efficient? Because what you're doing here is you're telling me that you're doing this through WCF. You're telling me you're doing this through the Windows Communication Foundation. By what all I know, that's using SOAP. And isn't SOAP horrendously explicit on the wire? What's the overhead for this? Guesses for the overhead? Yeah, tell me what the overhead is. Percentage. 2%. Stuart? 20%. No. Well, no, just for this TCP. If I take a TCP socket and make the TCP socket go through WCF with all the SOAP stuff. Okay, so the answer is smaller than 0.1%. And here's why. The Windows Communication Foundation employs a thing. So here's the contract. This is the heart of it. And that's what I want to show. Just want to show you quickly. So here's the heart of port bridge. I data exchange, I connect, I write, I disconnect. all I do. And the transfer buffer is basically a glorified version, an optimized version of byte array. It's just a trick so that I can avoid a single buffer copy. But that's really all that it is. Now, this is using NetTCP, so the standard WCF NetTCP mode in session mode. So you'll see that this is actually a no, that would have been funny. This is a session. It has a session mode enabled. I can't see that right now. It's small, too small. It's the screen resolution. So the session mode is enabled. NetTCP is using a Huffman-style compression on the wire. So it has all the W star standards, all of those strings, namespaces, tags, and all this stuff is preloaded into a dictionary. Both parties know that. So instead of transferring all those strings, it transfers a token. In session mode, it's learning. So everything that's metadata, namespace names, tags, attribute names, everything that's metadata around it, gets sent once and then replaced by a token. So that both parties share the same dictionary, and that shrinks down the size. The typical size of a SOAP envelope without message security, because message security destroys all of this optimization, because it encrypts before the encoder gets it in its hands. So without message security, if you just use transport security and just flow those things, typical overhead 43 to 47 bytes per message. That is not bad. If you use RM, reliable messaging, so if you put that on top, it's about 75 bytes. And with what we're doing here, we're tunneling raw binary streams, and I make the frame size between 48K and 65K. I'm dropping below 0.1% in terms of overhead. So it's really, NetTCP is really very, very, very efficient. And that's why this works. So, But this is TCP binary, NetTCP binary. Excuse me? Yeah, so authentication. So how do we authenticate? Every service bus endpoint is automatically protected by the access control service. So you are required to bring a token to connect to this. So we're exposing this as a .NET web service effectively. We're connecting to it as a .NET web service, and connecting to a service that's exposed through the service bus requires that you bring an access control token issued for you, bringing your password, that allows you to access this endpoint. So that's something that's built into service bus, that integration with access control. Everything is always secured by default. Something interesting also happened here, and that is this guy here. You can see this. We're looking at the service registry. The service registry allows discovery of endpoints. So we're looking at all the live services that are currently listening. Of this is, so the events, that's the one where we're sending all the diagnostics event through. Portbridge is the thing we're listening on locally, and orders is the thing that just accepted and processed our order. That thing is not running here. That thing is running on my machine at work. Because I can go and project from many sites services into this namespace. So I just chose to run this at work and make my work machine sort of the site of dinnernow.inc. So the workflows and the workflow database actually live now on my machine on Redmond campus, and I just interacted with them from here. How do we do this? How does that work? How do we take the workflow piece, and integrate that? That's for both workflows kind of the same. They used to live, if you compare this with a normal dinner now, they used to be hosted in the service portfolio in the service host. I broke them out, and I have now a separate service, and that doubles as a console app or as an NT service that's hosting those. So the program here is not very spectacular. It just goes and runs the DN order service, which eventually then goes and runs the DN order service host. If we go to the definition here, we'll find that it takes data from the configuration file and then just creates a workflow service host. So that's literally the same code, and then goes here as it gets opened. We're adding the transport client credentials, so the necessary credentials to actually be able to open up a connection into the service bus. We add that to all the endpoints that the workflow engine automatically adds, and then we go and start this, and the workflow, this WCF workflow service is automatically listening. For that, we need to have a little bit of configuration. This is just the tie-in again that we've seen before. This is the tie-in of the diagnostics thing into the CloudTrace listener, so we can look into that too. The interesting piece comes here for this section, where I'm building a custom binding. One of the things we had to do in this last milestone, or the last milestone release, is we had to cut a few bindings out. And that's mostly because we want to deliver a quality product, and therefore we had to jettison, at least for the time being, 5 of the bindings because we couldn't get the test coverage for them right. And that's just what happened. It's the reality of shipping a V1 product. Sometimes you have great aspirations in the CTP, and then you need to chop some things off. So we had to cut some things away. We had to cut some convenience features away, to be precise, because you can still build exactly the same things. Here's one of those examples. There's a custom binding. It's the W's HTTP relay context binding. Really what I'm doing here is I take the HTTP relay transport and combine that with the defaults of W's HTTP relay binding, which is just a text message encoder, and the context channel, which is required for workflow. What the context channel does is effectively shuttles cookies around so that you can always find the right instance. That's really all it does. So I just create this custom binding in my configuration, and then I use that custom binding for my client endpoints and also for the service endpoint here. So this is for the workflow. That's using my WHTTP relay context binding, and this is the main contract. So really all that's different from a normal WCF app here is that we're using the HTTP relay transport and not the HTTP transport. And that's really all that's different. So you can take any binding, any custom binding really, no matter how difficult it is, and just swap out the HTTP binding for the HTTP relay binding, and then you get to listen on the service bus and get the reach that you need to all of a sudden are listening from outside of your network. So that's what we've done here for exposing the workflows, and the other workflow looks exactly the same. So let's go and cut back to the slide deck and just recap what we've seen. What does the service bus do for us? The core capabilities is, so first of all, it gives you an internet scope sort of network overlay. It gives you a virtual network environment, if you will, where firewalls and NATs don't play so much of a role anymore. Firewalls and NATs are there to protect us from unwanted traffic. Unfortunately, they also protect us from wanted traffic. So that's something that Service Bus tries to fix here. So we can do service remoting. So normal web service calls in a duplex fashion or request response, as it happens with this workflow, or with the workflows. We can do tunneling with things like Portbridge, where we can take any raw protocol, may that be TDS, may that be SSH, may that be SNMP, may that be anything, and tunnel that through. Or we can just distribute events, as you've seen with the diagnostics case, where we can go and deal with that kind of traffic. So the content doesn't matter. We support JSON, we support XML, we can support basically any type of content. We support HTTP. You can listen on HTTP services. Clients can speak HTTP to you. You can opt in or opt out of the integration with the access control service. And what we're really building here is a service that allows you to bridge between sites, whether those sites are in the cloud and on-premise, or whether those sites are both on-premise, or whether those sites are both really laptops that sit in someone's lap on some wireless network. So one interesting story there. Preparation for Java 1, there's another sample that I owe you, which I'm going to also put up in the next 2 days. We were testing something for Java 1, and we're sitting in the Marriott in San Francisco. Me and the chief architect for the Sun Metro web services stack. And we're just sitting there. I had a reverse web proxy. I had a Sun Glassfish web server. The reverse web proxy is listening on the service bus and is forwarding HTTP requests. We were just sitting there, and he was giving me packages, and he was calling my machine, and he was calling his web services. And we're doing this on the Wi-Fi in the Marriott. And then we stopped for a moment. We're like, what we're doing here is kind of cool, because otherwise you just couldn't do it. The other thing is, the demo that I just ran, the last time I ran this was on Virgin America, 30,000 feet. And I saw the Windows Azure Cloud connecting into my machine on port 1433. That is also pretty cool. So you get all the connectivity options. When you look at the service bus, when you look at the things that you do, you should look at WCF really as a universal plumbing kit for communication. That's the way you should look at it. It's not a web services stack, really. We give you one-way connectivity. Think of net one-way and net event, or even net TCP binding in one-way mode. Think of that as a datagram transport. That's your equivalent of UDP. Think of a net TCP binding, even the on-premise one, or net TCP relay binding. Think of that with duplex as a socket kind of thing. It's just, don't say write and read, you just send a message. And the added benefit is that we're giving you is we have a formatter. We can take your data structure and turn it into bytes, and we can turn that back. And then we're request response. Yes, we do the correlation for you. But it's a universal kit, so you can have datagrams, you can have uncorrelated datagrams, you can have request response. And as much as you have that on-premise with WCF, we're now taking that and we're expanding that to the cloud. We give you all that reach. We give you discoverability, as you've seen with the service registry. And we give you all those capabilities. And as you've seen, if you use those things right, and I'm giving you the tool so you don't have to do it, you can tunnel any arbitrary protocol over these, and you're not constrained by XML or HTTP or any of those things. Take whatever you have and bridge it over the service bus. So we have 3 patterns. Let's go and review those quickly in the last 2 minutes. We have eventing, service remoting, tunneling. We saw those. First pattern family is eventing. What we've done here is we use this for diagnostics. We have a capability that we call the message buffer. That's a little queue-like thing. That's ephemeral. The data is not persisted. So if the message buffer, if that machine goes away, then the messages go away. So we give that to you for elasticity and for occasionally connected clients. And that's a one-way mechanism, so you can do all those things, whatever kinds of notifications you have. We use this very extensively for diagnostics. Service remoting, you have the purchase order that just flowed, so we have the traditional SOA scenario, where you have services, you have strongly schematized data. You want to flow that between different sites without being intrusive into the network. You have multiple departments trying to work with each other, not necessarily getting the most friendly reception for that by their IT staff if they want to do something technical, because if they walk up to them and say, hey, open up that firewall, they get laughed at. So if you want to realize tactical things very quickly, you can do that very, very well with the service bus. And then the pattern family 3 is tunneling. I showed you the socket bridge model. I talked about the name pipe bridge model. The HTTP bridge is also on my blog. There's an article that talks about the kitchen table and how you can host an HTTP server there. I'm going to update that sample so that it actually is capable of dealing with SOAP. And we have tested that at Java 1 together with the Sun guys so that it actually works with a Java application server in the background. So if you want to have listener capabilities of exposing existing HTTP services that may run on in other runtimes, then you can use that reverse proxy solution that we have to go and bridge to those. I'm going to publish those updated bits. So in summary, no other cloud platform does what we do. You don't have those options anywhere else. The closest you can get is some options from some VPN options or some, give me your database options from someone else. But pervasive connectivity from the cloud into your data centers or between your sites, you don't get from any other platform. And you use the tools that you know. It's WCF. It's all documented. You can use existing bindings. You can use all your extensions. So it just works. If you have any questions, windowsazure.com, we have forums, we have all those things. And if you have something really interesting or something really hard, you can send me email, and I'm going to forward that to the right people. And I think for attending this session, if you come to our booth later, you can get a mouse.
They were out.
Oh, they were out already? Well, then you can't get a mouse. So, and of course, fill your evaluations. I believe we're actually giving money to charity for every single for every eval that you fill out, so that's a great thing. And with that, I thank you for your attention.